Hi, my name is Varun with roll number S372382. Today, I'm presenting a project titled Credit Card Fraud Detection using Machine Learning and Deep Learning with my other colleagues, Mohammad Uzair and Afaq Rafi. So first of all, we have introduction and motivation. Credit card fraud is a big problem for banks. Fraud leads to money loss and customer trust issues. Goal detect fraud accurately, reduce false alarms. Compare ML and DL models for performance. Credit card fraud is a serious problem in banking. If fraud is missed, bank lose money. If normal transactions are blocked, customer lose trust. Our aim is to build models that detect fraud correctly and reduce false alarms. We will compare machine learning and deep learning model to see which works best. And the other slide is about dataset description. Source Kaggle dataset, size 1 million transactions, feature 7 distance transaction details, online order, chip, PIN, etc. Target fraud 1 or legit 0. Fraud rate 9%. Visuals pie chart of fraud versus legit. We used a Kaggle dataset with 1 million credit card transactions. It has 7 features like distance from home, whether it was an online order, if a chip or PIN was used, and others. The target column tells if the transaction was fraud or not. Only about 9% of the transactions are fraud. This imbalance makes the problem challenging. The next slide is about dataset analysis, which is also called EDA. No missing values, no duplicates, fraud linked to higher purchase ratios, more online orders, no PIN, no chip, non-fraud linked to chip plus PIN use. Visual box plot, stack bar chart. In our dataset, there are no missing values or duplicates. From our analysis, we found that fraud is often linked to higher purchase ratios and online orders. Fraud is also more common when transactions did not use a PIN or chip. Legit transactions are more often done with chip and PIN. The next slide is about feature importance. The most important features are ratio to medium purchase price, online order, and distance from home. The least importance are repeat retailer. Visuals, bar plot of random forest feature importance. We checked which features are most useful for fraud detection. The top 3 features were ratio to median purchase price, whether it was an online order or distance from home. The equal retailer feature had a very little impact on fraud detection. The next slide is about progressing and transformation. And now I am handling this slide to my colleague, Afaq Rafi.
Hey, Afaq here with roll number S376356. So I'm starting with my slide about pre-processing and transformation. As shown in the slide, they are showing train test split 80% train and 20% test, and also scaling applied for Navy base and ANN, and also fraud imbalance handled with class weights. Visuals follow diagram of processing steps. We prepared our data set before training. We split it into 80% training data and 20% testing data. We made sure the split was stratified so the fraud ratio stayed the same in both sets. We scaled the features for models like Navy Base and ANN, which work better with normalized values. Since fraud causes are much fewer than normal ones, we used class weights. This gave more importance to fraud cases during training. This way, the models do not ignore fraud just because most transactions are normal. And my next slide is about, you can see the next slide is about decision tree model. In that slide, as shown in the slide, we are talking about the simple tree structure and easy to understand and can overfit it if not controlled. And also results are almost perfect accuracy but risk of memorizing data. We use a smart decision tree diagram. Our first model was decision tree. A decision tree is a simple and easy to understand. It splits the data into branches based on features values. It is fast and gives the clear rules, but it can overfit the data if the depth is not controlled. In our case, the decision tree gives almost perfect accuracy on test data. but this could mean that the tree memorized patterns too closely. So, while the accuracy looks great, we must be careful. The model may not always generalize well to unseen data. And the next slide, as you can see about the random forest model. So in that slide, you can see on the right side, they are showing ensemble of many decision trees and more robust, less overfitting, and results near perfect accuracy. Visuals are random forest diagram, many trees combined. Our second model was random forest. Random forest is an ensemble model that combines many decision trees. Each tree looks at a random sample of data and features. The final prediction is based on the majority vote. This reduces overfitting and makes the model more robust. In our project, Random Forest gave excellent results. It had near perfect accuracy and a ROC/AUC of 1.0. This means it could separate fraud and non-fraud almost perfectly. Random Forest performed slightly better than the single decision tree. And the next slide is about Navy Bayes model. In this slide, as showing in the slide, we're talking about the based on probability and Bayes theorem. Works well for text and simple data, assumes features are independent, and also results 95% accuracy, weak fraud recall 59% almost. Visuals, Bayes theorem formula of probability diagram. Our third model was Navy Bayes. This model is based on probability and Bayes theorem. It works well for simple data and is very fast, but it assumes that features are independent from each other. In our dataset, this is not true. Many features are related. Because of this, Navy Bayes did not perform as well as trees models. It gives about 95% accuracy, but it recalls for fraud was only 59%. This means it missed many fraud cases. Even though accuracy looks fine, the low recall makes it a weak model for fraud detection. And my next slide is about ANN, like you can say MLP model. In my slide, you can see as shown, we are talking about two hidden layers, 6432 units with dropout. Dense complex patterns in data. Results are 99.8% accuracy, like ROC/AUC, like equal to 1%. Visuals are ANN architecture diagram. Our fourth model was an artificial neural network, also called a multi-layer perceptron. It had two hidden layers with 64 and 32 neurons. We also used dropout to avoid overfitting. The activation function was ReLU for hidden layers and sigmoid for the output. This model can learn complex pattern in the data. In our project, the ANN gave very strong results. It achieved about 99.8% accuracy and a ROC/AUC score of 1. This shows that the ANN could identify fraud and non-fraud very well, almost at the same level as random forest. The next slide is about model results confusion matrices. I wanna pass to my another colleague, Muhammad Uzair Khan. He will explain about this one.
Hello, my name is Muhammad Uzair Khan and my roll number is S3751, and I'm here to present model result confusion matrix. In this you can see decision tree, random forest, Naive Bayes, and ANN. You can see decision tree, random forest almost perfect classification, and ANN very high accuracy. Naive Bayes weaker, missed many fraud causes. So usual for confusion matrix heat map you can see up on the slide. So if we talk about in details, here are the confusion metrics for all models. The decision tree and random forest models predict almost all fraud and non-fraud cases correctly that I already mentioned. The ANN also performed very well with only a small number of errors, but the naive basis model made many mistakes. It misclassified many fraud causes as normal. This is a very big problem because in fraud detection, missing fraud can cause money. Yeah, money loss. These confusion metrics shows us while accuracy may look good, the real difference is how well models fraud causes. So that's the confusion metric results. Going to the next slide. Yep. So you can, the next slide is model results ROC curves. You can see on the right hand side, there's a curve, and you can see there's ROC shows model ability to separate classes, decision tree, random, forest, and a near perfection of 1 point AUC 1.1 and dot 0. And naive basis weaker, AUC is 0.96, and there's yep false positive rate FPR. So in this slide, if we talk about the detail, the ROC curve for all models, ROC curves measure how well models can separate fraud and non-fraud. A perfect model will be close to top left corner. In our case, the decision tree, random forest, and ANN all perform almost perfectly. With AUC close to 1.0, the naive basis model weaker. With AUC of about 0.96, I already mentioned this everything, and this shows the while naive basis is acceptable, the tree models and ANN are much stronger for this task. Coming towards the next slide. Here you go. And the next slide is model results, precision, recall, and curves. PR curves are better for imbalanced data. ANN, RF, DT, very high precision and recall. Naive basis, weaker recall, low average precision. And in visual, you can see PR curve for all the models. Yeah. Because of the dataset is imbalanced, precision recall curves are most useful than ROC. Precision shows how many predicted fraud were correct or not. Recalls shows how many recall fraud were caught, or ANN, random forest, and decision tree all had excellent precision and recall. Naive basis was weaker with lower recall. This means it missed more fraud cases. The baseline precision was only 0.087, but our strong model were far above this. This clearly shows which model are effective for real fraud predictions. Coming to us on the next slide. Next slide. Yeah. This is the model comparison table. In this slide, you can see the table of metric accuracy, precision, recall, F1 score, or ROC, AUC. Decision tree and random forest, almost 100 and 100%. ANN 99.8%, naive base 99%, but poor recall. In visual is you can see there's a table, matrix table with color in highlights. That the table compares all four models using different metrics. Decision tree, random forest had almost perfect result across all metrics. The ANN also performed very well with accuracy of 99.8%. The ROC, AUC of 1.0. Naive bases were much weaker. Its accuracy was still 95%, but its recall was only 59%. That is very low. This means it failed to detect many fraud cases. That's not good for our result. This comparison shows why it is important to look at more than just accuracy. It's in fraud detection, recall and F1 score are very important. Yeah, coming towards the next slide. Yeah, this is a discussion of results. In this, you can see both charts. Tree base models and ANN are best. Naive bases not suitable for fraud detection. Strong features explain high accuracy. Important to balance recall and precision. Our result in this, you can see our results. Our results shows that tree-based models like random forest and deep models like ANN and are the best for this fraud detection, and like credit card fraud detection. For database, this they gave almost a perfect result and caught almost all fraud cases. The knife-based model is not suitable because it missed many fraud cases, even though it had high accuracy overall. One reason the strong model performs so well is because the feature in the dataset is very predictable. Features like purchase ratio and online order give clear signals of fraud. In real world systems, recall and precision are very important than accuracy, because missing fraud can cause heavy losses. So that's it from this slide, and coming towards the next conclusion. Yeah. Uh, in conclusion, best model, I can say random forest and ANN. Gaussian trees works, but risk of overfitting. Knife base is weak baseline, and importance of a strong feature in fraud detection. So the best model like were random forest and ANN, but both achieve very high performance and are very suitable for fraud detection. The decision tree also work very well, but overfit is if not controlled. Knife bases act as simple baseline, but it's not strong enough for the task. Our study showed that how important it is to evaluate model on many metrics, not just accuracy. We have to check F1 score, precision, recall, everything, not just accuracy. It also shows how strong features such as purchase ratio and online order can make fraud detection easily. In practice, a random forest model would be a good balance between accuracy and development. Thank you. That's it from my side, and thank you so much.